Javid. I'm one of the product managers for Cullen, and I'm pleased to introduce today's host, Craig Smith, who's also a product manager on the Cullen team. And Craig has been the driving force behind the development of all of our new hangers materials. So while we're running this webinar, the purpose of today's webinar is to address knowledge gaps in the market concerning hangers identified through our offsite customer-backed innovation process. These gaps span various stages of the supply chain from design to on-site installation, and this webinar is the second installment of our external hangers campaign, comprising of product spotlights, new and refreshed video content, and new site-focused technical documentation, which we'll be sharing at the end of this webinar. Like our previous gable restraint and straps webinars, our goal is to inform, engage, and share best practices related to our Cullen floor hangers. Craig will provide an overview of our hanger ranges and their applications, focusing on the what, why, and how for both timber and masonry hangers, as well as covering steel connections, fixing requirements, hanger selection, and practical guidance. He will also present both new and existing materials related to our Cullen hangers. After the presentation, we'll have a Q&A session with Martin Cox, our new Senior Engineering Manager, starting in January. Please hold your questions until the Q&A session. However, as I said, you can submit them at any time using the Q&A button at the top of your screen. Alternatively, if you would like to say your question out loud, please wait until the Q&A session and use the raise hand function at the top of the screen, and I'll address you as to when to ask your question. One thing separating this webinar from our previous webinars is that Cullen is now an official CPD provider, and this webinar is CPD accredited. In order for you to achieve the accreditation points, we needed to include a learning objectives slide for the webinar. So the aim for this webinar is to understand why hangers are used in construction and what they do, be familiar with the range of masonry and timber hangers Cullen provides and their applications, be confident in picking the correct range and size of our Cullen hangers, and develop a good understanding of how hangers are installed. Also, we've replaced our usual feedback form with more of a lessons learned form. So in order to get the full points and accreditation, please fill in the lessons learned form, which we will share at the end of the webinar. Once that form is completed, we'll email you your CPD certificate. Okay, so that's enough from me. I'll hand it over to Craig to guide us through today's content.
Hi everyone, and thank you, Mo, for the introduction. Before we get into some of the more detailed aspects of the hangers, what we'll do is we'll just very quickly go over why hangers are needed. So hangers connect joists to masonry or timber, either in the floor or the roof. For this webinar, we'll be focusing on the floor applications. The floor hangers can support multiple joist systems. We can see here I-joist, metal web joists, and solid timber. The joists span open areas, just creating a floor space with services where services can go and to help aid sound dispersion. The hangers connect these joists together, as we can see, forming a structural grid that attaches the floor to the outer walls as well. And then we can see a closer up image of the hangers on the right at that junction where we've got a joist joining onto another joist. The important thing to note when considering hangers are the standards and regulations around them. So hangers must comply with these regulations for safe and also legal use. The key documents to highlight are Approved Document A for structural rules in floors and roofs, the NHBC standards, installation guidance and performance expectations. And then we also have two documents that relate to quality, so a BSEN 845 and then an ETA that we have for timber components. The BSEN is for masonry, and these are just for component quality, as I said. While the NHBC logo is on the screen, and I'll hint to this throughout the webinar, but just to point out that hangers must support 60% of the joist depth, or at least 60% of the joist depth, and this just prevents any twisting and ensures that the hanger performs as it should. But as I said, I'll sort of hint to that as we go down, but that is a NHBC requirement. So to start off, we have a selection of timber to masonry and timber to timber hangers. We will look at the timber to masonry hangers first, and we can see the range on the screen. So we have the JHI, which is a sort of standard load hanger. And then moving on to the higher loads, we have the RBJHI and then the FMHI, which is a welded option. Past that, looking into the very high loads, we have the masonry standard, which also has a return option. The FMHI and the masonry standard are welded and they're made of thicker steel, which allows them to achieve those higher loads. So we'll go over some of these products in a bit more detail, sort of describing their applications and their use. So the JHI hanger is the masonry hanger. It supports I-joist, metal web, and solid timber. So it's one product that suits all of the joist systems. It sits on the masonry wall, as we can see here, and it's supporting an I-joist. It is fixed with our standard square twist nails. Most and all, pretty much, of our hangers are fixed with our standard square twist nails, which we'll see further down the line. You might hear me say square twist nails quite a lot. The important thing with the JHI, the important thing to remember is that there is a minimum of 3 courses required above the blockwork to achieve the load values. If that blockwork is not there, then the load value can decrease. So the blockwork adds to the final load of the hanger. And it's also important to note that that blockwork needs to cure for 28 days to allow you to load the floor. There are circular holes on the hanger. These circular holes are for the nails to go into the incoming joist. And this will be on the bottom flange of the joist usually. And there's no masonry fixings that are required for the JHI. Some of the installation don'ts as well. The hanger should be tight against the blockwork, so a maximum gap of 6 millimeters between the joist and the back of the hanger, and the joist must be fully seated. We can also see in these images that there's a JHI hanger sitting on top of timber. The masonry hangers should only be sitting on masonry and not timber. The timber has the potential to crush under the load of that JHI hanger. There's also some upstands on the masonry hangers. These help secure it into the masonry wall. If you flatten them or bend them, damage them, then that can potentially impact the performance that the JHI or other masonry hangers will have. Also important to note is that sometimes you may require restraint straps along with these hangers, but that is dependent on the design and the location of where they are in the floor. Moving on from that, we have the sort of upgraded version of a JHI. Same application, but the installation varies slightly. It supports, again, I-joist, metal web, and solid timber. The key difference being that top reinforcement plate. This can increase the load capacity by up to 183%, so it really does make a difference. And again, fixed with our standard square twist nails. You might be wondering what the RB stands for. It stands for rapid build. The reason for this, there is no masonry required above the RB JHI. So it sits on the blockwork. The blockwork needs to be cured for 3 days or more, and then it is safe to load that floor. You do have the option to add more blockwork, and this will increase the load capacity. So we have 2 load capacities for this, one with blockwork above and one with it without blockwork. And this is in our technical guide, so you can see those. So it's very important just to be careful what you're specifying. Some of the benefits with it for not needing that blockwork above is that you can build a bit faster. Your internal walls and the next story of blockwork can be built sooner, and it reduces some working at height risks that can be involved. The installation of the masonry hangers doesn't affect any wall airtightness, and this has the same common errors that you need to look out for. So making sure that the joist is fully seated, the hangers tight against the blockwork, and not to bend any of those upstands or the circles that are the holes that are in the hanger, as these just help secure it into the mortar. I mentioned earlier about circular holes. These circular holes are for the bottom flange, and they should always be nailed to secure the incoming member. For enhanced uplift, we can also take advantage of these triangular holes that are in the products. So we need to nail through these into either an end block, a web stiffener, or solid timber, and that can improve the uplift performance by up to 125%. But it's important to note that we need a full story of masonry above that to achieve the loads. So we've got downwards loads, and then we've got an improved uplift if you're using the additional triangular holes. Moving on, if you're looking for applications beyond the RBJHI's capacity, we're looking at things that are like the FMHI, which is a welded hanger made of thicker steel, more high load structural openings sort of area. The FMHI comes in different configurations. We've got dropped, skewed, and offset that you can see there, then also a straddle and a return. The higher load option compared to that, so even further down the line, is the masonry standard or the masonry standard return. These are painted for corrosion protection, so when you see them, they'll often be black hangers. And the welded is just a flexible option for more complex designs. Another sort of application that you can use the JHI for is steel beams. So we can use this hanger if you've got any steel in the building and you're looking to support the floor. If there is masonry above, you should be using the JHI or the RBJHI. If there's no masonry above, you can use either the masonry hanger or a timber hanger. We'll get onto those details shortly as well. The fixings required for this are specified in the technical guide, and they're these spit fixings, which you can see on the screen. And these are shot fired directly into the steel through the small holes on the RBJHI and the JHI. So the JHI covers masonry to timber and then also masonry and steel applications. I mentioned this earlier on, but timber to timber hangers is what we're going to go through over the next few slides, very similar fashion to the masonry hangers that we've just done. So the timber to timber hangers work with I-joist, metal web, and solid timber as well. And then we have a range that includes standard through to very high load hangers. We've got the UH, which is the universal hanger, the heavier version of that, the HUH, and then the MH range and the FTHI, which is the welded version. The MH range is similar load values to the HUH, but can be used as an alternative, and we'll go into that as well. Starting off with the UH, it's the typical floor hanger for timber to timber connections. It supports all the joist systems, giving it that sort of universal name, so the universal hanger. In our technical guide, we detail 17 applications, so a lot of varied uses that we can do with this. It's fixed again with our standard square twist nails and has an efficient nailing pattern that reduces the amount of nails that we need and can increase the load. The size range goes from 220 to 300 millimeters deep, and then the width is 39 to 100 millimeters deep. If you want to go past 100 millimeters wide, we'd be looking at the HUH hangers, and we'll look into them as well. But before that, just want to touch on a few of the UH applications and the sort of standard and enhanced versions that we can do. So this is the joist to joist connection. What we're looking to do here is nail all those red circular holes, and the top tabs, the header face, and the sides of the incoming joist should all be nailed. This is a total of 14 nails. And then there's minimal performance difference between the metal web and the I-joist, so you're getting consistent strength across both the systems. So this is just the standard sort of procedure, and then you can see the red holes that are highlighted there. To improve upon the loads, we're looking at additional nailing into some triangular holes, a bit like the ones that were on the JHI for uplift. With more nails, we can achieve higher loads. The total nails in the enhanced option is 24 to 26, which is 10 more than the standard option, and this increases the load rating to just over 20 kilonewtons. So you can see the figures on the screen, but how much it's improved, it's also dependent on the joist system, so something to look out for. With solid timber, it's pretty straightforward to add in those extra nails. With I-joists or metal web, we'll need to add some timber behind those nail holes. So with the I-joist, we're looking at adding a backer block. And then with the metal web, we'd be looking at putting in a gusset. The uplift capacity, sorry, the uplift capacity is unchanged. So we're not improving that at all in this detail. And then when you're nailing the metal web through the plywood gusset, or when you're nailing the hanger through the plywood gusset, it's important that you probably use a PPN gun, as the nail needs to be fully embedded into that plywood and it might end up needing to pierce the steel behind it. I mentioned a gusset detail, so we have some details in our technical guide for this as well, and it supports the enhanced installation. It requires 8 PSTS screws. We've got 4 at the top and 4 at the bottom. And then it's important to maintain a proper edge distance for a strong connection. You can see some of the minimums detailed on the screen. And then the plywood gusset must cover the full depth of the joist and ensure that there's clearance on either side of the hanger for the fixings as well. So you can see here the hanger is quite central, and then the spacings or the fixings are spaced quite nicely either side. Like the JHI, we can do an enhanced uplift, so up to an additional 6 nails into the triangular holes in the incoming joist to increase the uplift. You can see they're highlighted in red. I-joist will require a web stiffener, and the metal web joists, those nails can go directly into that end block of timber, so we don't need to do anything with the metal web. We just need to add a blocking piece into or a web stiffener into the I-joist. The uplift resistance improves by up to 200%, and we can combine this with the enhanced downward load installations for maximum connection strength. So we get the most benefit out of the UH by doing this. Something that is unique to the UH is the sacrificial stairwell option. So it's for temporary floor infill details. It has reduced fixings, and we can also use screws with this, as you're more likely to be needing to take the hanger off afterwards. It has a lower load capacity than the standard or the enhanced UH. It's reduced by almost half. You can see the top tabs are either on or off, so they're optional, and they can just be removed along a snap line by giving them a wiggle, essentially. But they are very important and do perform well, which we'll see later on as well. The uplift capacity is unchanged, and this is just a really practical detail for filling temporary openings in floors during construction, such as a stairwell. And then very quickly, I thought it'd be good just to go over how the UH is installed. So we're placing the UH onto a header, nailing it into the header, either standard or enhanced, and that depends on the load that we're putting through the hanger. Snap off or nail the top tabs if they're specified, and then place the incoming joist and nail that nail that as well, whether it's uplift or it's just standard uplift. For the UH, an extended application of it is if we're looking at joists between 350 and 450 millimeters deep. So the maximum height of the UH is 292 millimeters. So in order for it to accommodate that 350, 450 millimeter deep joist, we need to restrain that portion at the top, which is the UZ clip, and this helps hold that portion at the top, that top cord, and stops it from twisting, essentially. So nail all the red highlighted holes, so that's 28 nails, and you can see the top tabs are included with the UH, plus the ones in the UZ clip. To do this, you would start by installing the UZ clip onto the incoming top flange before installing it onto the header as well. Then you would install the UH, as we can see here, and this has a similar, the load is similar to the standard detail, but the uplift is slightly reduced. This is also for single joists only, so not to be used for double joists. When you want to go to double joists, there's another hanger, another detail that we can look at later on. So Past the UH, we have the HUH, which is the heavy universal hanger. Again, timber to timber hanger for floor connections, and it supports the 3 joist systems, making it universal. It has 13 detailed applications in our technical guide, so again, quite varied, and also fixed with our standard square twist nails with an efficient layout that reduces the amount of nails that you need and can increase the load. So what we're looking at here is the standard application for the HUH, and we can see it's quite similar. We're nailing all the circular nail holes. What I would like to point out is the nails at the top. So we can see that there are a total of 4 into the rear header and 2 into the front header. So ensuring that you've got the correct fixings into the headers, and then also the ones into the incoming and the face of the header that are required. The total nails for this is 24, so there's 10 more than the UH, so we're getting a higher load, and then also it's a bigger hanger, so that impacts the load as well, so we're improving just by having a bigger hanger. The triangular holes do exist on this as well, but they are for the enhanced options, not for the standard use. And then the size range is a depth of 220 to 400 millimeters with a width of 39 to 300 millimeters with a selection in between that range. So with the UH, we can go to a maximum of 100, and then with the HUH, we can go up to 300. The standard setup for the metal web is similar to the I-joist, but we also have this additional detail where you can add blocking to the joist. This reduces deformation and improves the performance in that area. So to do that, we're fixing a block with 2 pass load ring shank nails, one at the top and one at the bottom. And the load capacity can increase up to 29% with that blocking. So if you're looking for a bit more out of the connection with the HUH, you can use this. For the enhanced installations of the HUH, we're looking at additional nails into the triangular holes. So again, similar story to the UH. And it's a total nails of 30 to 36. For solid timber, we're nailing directly into the header face. But for I-joist and metal web, again, we need to add some material behind the holes. So that's either a backer block or the gusset, so that we can get those extra fixings in. And then again, just a nod to, it's probably useful to be using a PPN at this point if you're installing onto metal web, as the nail will need to potentially pierce the metal web in order to get good embedment into the gusset. The load capacity increases from it was less than 20 kilonewtons to around 30 kilonewtons by doing this application, and also similar sort of nailing for those top tabs. The header nailing rule is minimum of 4 nails into the rear header and 2 into the front header. So keeping the same rule. With the HUH, we can go to enhanced uplift. So we're adding 4 nails into the triangular holes on the incoming member. With an I-joist, we'll be using a web stiffener. For metal web, we want to potentially insert a bit of timber that's the full width of the joist, and that could be 20 to 40 millimeters forward from the rear of the hanger, just to ensure that we have some material behind those nail holes. The extra nails equals increased uplift. More nails, more load. And then very similar, just the HUH installation, which is almost identical. Position the hanger tight against the joist, nail to the flanges of the header, as per the detail, so whether it's enhanced or the standard, and then fold the top section over. You can't snap these off, and nail them down. And then this just final step would be to ensure that the joist is properly seated, the incoming joist is properly seated in the hanger. The final timber hanger that we're going to go over is the MH. So you can see there's a few different variations of this. It's a timber to timber hanger for floors and roofs. But again, this is mainly floors that we're focusing on today. It's compatible with I-joist, metal web joist, and solid timber. And we've got internal and external flange options, which you can see. These are to avoid clashes with surfaces or edges, maybe around openings. And then you can use nails or bolts for higher load requirements. So it's a flexible sort of installation, which is ideal for complex timber to timber connections. Again, using our square twist nails. These are face fix only hangers, so there's no top tab like the UH or the HUH. So it's really important to make sure that the joist covers at least 60% of the joist depth. Oh, sorry, the hanger covers at least 60% of the joist depth. The number of nails required can be higher than the UH or the HUH, so we're looking at 19 to 56 nails. That's dependent on the application and the size of hanger that we're looking at. The bolting option, that can add 2 to 7 kilonewtons, but the loads, it's sometimes nails do give a higher load depending on the amount of nails that you're putting in there as well. So we'll see that in one of the tables later on when we're looking at the fixings and how it impacts the load. Important thing to mention here, if you're using solid timber and an internal flange option, it's important to notch that solid piece of timber so that we can get the timber around the bolt heads and it's seated nicely if you're using the bolted option with solid timber. I mentioned the UH detail for joist depths between 350 and 450. That is only for single joists. When you want to go to 2-ply, we can use this MHE detail. So for double joists, we're looking at this. It's not really for use for single joist, but single joist is the UH. It's very similar. We're using 2 UZ clips to secure the joists, and then there's an I-clip connector as that extra piece of metalwork which holds the joists together. And this provides nearly double the load capacity than the UH detail, so it's essential for 2-ply joists when you've got heavier loads coming in. That was maybe quite a lot, so I'll try and summarize it a little bit based on sort of what we've been talking about. The UH is the most economical. It will do most of the applications that you're looking for. And it also has that sacrificial stairwell option. It will go max 100 millimeters wide and 300 millimeters deep. So to go past that, you'll need to go to the HUH. The HUH is for larger, stronger joists, which is ideal for double joists, trimmers, and beams at openings. These are higher loads for more substantial beams, essentially. Then we have the MH range, which is internal or external flange options, and these are face fix only. The internal flange helps to avoid clashes, which is useful if you've maybe got close hanger spacing. The external flange kind of gives a similar load to the HUH, and it's designed for solid timber as well. The FTHI is just the stronger version of these, and it's welded. It's top fix as well, so you need to take into account that the top material thickness of the FTHI if you're building this into timber, and it's just for even higher load capacities. Along with timber to timber applications, we can also use the UH and the HUH on steel. So we've got multiple steel connection options that we can use. We have the standard, which we can see on the left with the 2 of them. We have the hanger fully against the steel packer with the top tabs included, and it relies on the triangular holes for strength as well. So we'll be nailing all the holes here. The dropped installation, which we can see is the 3rd one along. The hanger sits below the steel beam and relies again on those triangular holes for strength. You can also see that the hanger rests on the steel and not on a packer. And this would just be shot fired using those steel fixings, which were used for the RBJHI and the JHI as well. And then we can see them at the bottom of the screen. The correct configuration just depends on the load requirements and the site constraints that you're dealing with. So the hangers can be installed in different ways, mainly the UH hanger. We can fully face fix to a steel packer for the maximum load, so we're nailing all the nail holes here. or we can drop below the steel beam, which we're reducing the fixings, we're reducing the load. We can also have a raise above the beam or central. Again, as we're reducing the fixings, we're reducing the loads. There's a 30% rule, so if we are raising or dropping the hanger, we only want to do it by a maximum of 30% of the joist depth. You might ask why. So the steel hanger drop limits are in place because an excessive amount of drop below the steel can cause under rotation, making a sloping bearing surface that the joist is relying on. The slope is structurally inefficient and it will reduce the load capacity, and then also the side flanges may buckle and we're risking premature failure. So always follow the guidelines for max drop distances for our timber hangers, and these are in the guide and you can see them on the screen in front of you as well. So very important. Past the applications, we want to make sure that we're selecting the right hanger. So this is often done in software, but to double check it, we can also do it manually. So we're looking at starting with the joist width. Select the hanger width that is equal to or just above that. So here we've got 61. And then check the joist depth. So in this case, we're 235. And then we're using the selection table to find the intersection between the row and the column. And we've got the UH61 235. And then, as I said, it's usually specified in the software, and this would just be a manual approach of doing it if you want to check. It's important to ensure that the hanger fits properly. If there's too large a tolerance or a gap either side, it can impact the load performance. So here we're looking at the load values of the application. So each hanger application has a load table in the guide. The load values given are in characteristic capacity, which is an industry standard format for consistent design approach. And these are derived from the design load under EC5. The software that you're working on might show metalwork characteristic capacity, and you can compare these with our technical guide. And then using characteristic capacities just ensures that it's a standardized and reliable approach for everyone. The fixing quantities you can see are also detailed in the same table, which are also pretty important. So if we move on to the next slide, we can see that we're looking at fixings and we've got header and incoming. With the header options, we can see we've got either 30 nails or 6 bolts. And then if we look at the characteristic capacity on the right, how the load can be impacted by how we're changing the fixings. It's important not to mix the nails or the bolts. These are an untested combination and we're risking some performance and then also maybe safety. Another thing to consider are the top tabs, especially on the UH. So the top tabs significantly affect the load capacity. We have the standard installation with the top tabs, which you can see. That gives us 13.23 kilonewtons. Without the top tabs, we're 7.43 kilonewtons, so nearly half. So those top tabs do a lot of work, and they're crucial for the performance of the part. So always install per any technical guidelines, and it should be installed however it's been specified. And then just a quick one in terms of ease of use, in terms of our catalogue or our guide. In terms of, well, to select the right hanger, we want to start by identifying the connection. So is it timber to timber, or is it to masonry, or is it to steel? The technical guide that we're looking at categorizes this masonry, engineered wood, or roof. And then the next step would be what load are we looking at? Is it standard or high? In this example, we're looking at a timber to timber hanger. So we've gone to a summary page essentially, and then we've identified that we're looking at the standard load, and then we can look at a little load table there as well. And then just a quick navigation tip on our technical guide is that the contents page often has, or it does have, some in-document links, so you can click on them and it will take you straight to where you want to go. In terms of fixings, all our Cullen hangers are CE marked and tested to ETA or ETAG 15 using 3.4 and 35mm square twist nails only, unless it's specified otherwise. It's a standardized nail type for on-site simplicity, and there's no confusion on the fixings when we're on site. There's no risk of the nails being wrong, and it's one nail type that meets all of our load values. Just ensures reliable, consistent performance as we've tested it. And then it can also be installed either by hand or with a pass load PPN nail gun. So all we've really looked at is drawings so far. So this is a kind of show of images for real world applications. Here we can see the UH with a backer block, which is the enhanced sort of downwards load. That's the first image that we're looking at. Then we have the UH on a steel, or on steel with a packer on it. Then we have the UH sacrificial stairwell, so the top tabs have been taken off as well. And then we have masonry hangers, which we can also see in some of the images. There's a parallel restraint strap in. We have a restraint straps webinar that we've previously done, so if you're interested in that, you can go and have a look at that, and there's also some videos on our YouTube channel for installation videos. The technical guide provides all full installation details, so if you're looking for an application, I would visit the technical guide, and then if it's not there, you can contact some of our technical teams. So we'll watch one of our installation videos, and then we'll progress onto a few more slides before we open up with the Q&A. The video is just providing a short break from me speaking. And the full playlist, so this is one of the videos, but the full playlist covers a range of scenarios from steel connections to timber installation, covering UH and our RBs and JHIs. And then, as I said, after the video, we'll go through a few other slides to finish off, and then we'll open up the Q&A. So the video does have sound. If you're not hearing anything, it's just a wee technical glitch. But when you are watching the video later on, you can have a wee boogie to the sound. Yep, so we have other videos like that that you can go and have a look at on our YouTube channel for the various products that we spoke about today as well. Before we move on, we've just got this hanger checklist that we've made up, and it kind of summarizes, make sure that you're picking the right hanger. So is the hanger suitable for the application? Does it meet the load value requirements that you're looking for? Is the hanger the correct size for the joist or truss? Is the hanger, or sorry, do you meet the 60% depth requirement that the NHBC are talking about? And have the fixing details in the installation process been considered? So considering the fixing type and the compatibility for proper installation and the performance. So all things that you maybe need to think about before finalizing that hanger detail. The typical issues that we might see with some hanger installations. So hangers might be used in untested scenarios, so scenarios they're not designed for or certified for. Installation mistakes can happen. You might have misalignment, from or incorrect placement, which compromises the structural integrity. And then people using untested fixings, so fixings that we haven't specified. And this can affect the performance because we're maybe not sure what it'll do because it's not been tested. On-site improvisation as well. So sometimes there are quick fixes, they're not tested, and also, again, maybe unreliable. The consequence, floors might lack proper support. So it's important to make sure that the installation is right first time and we're saving any issues down the line. So next, we'll look at a couple of real examples of how it can go wrong. We'll break them down a little bit. So mistakes happen for different reasons. Site teams might follow drawings directly, even if there's a mistake. So it can be interpreted differently as well. The JHI hanger with no support underneath it is the first one that we can see. It's not correct. It's not resting on anything, that blockwork, or there should be blockwork under it, and it's not providing the full support that it needs. The hanger is too wide in one of the other pictures up the top. This allows for movement and the fixings don't engage properly. And then on the one to the right of that again, we've got joists that are too close together. This prevents correct nailing and it weakens the connection. So again, we're maybe limiting the amount of performance that hanger can do. And then the one at the bottom, we've got the two RBJHIs stacked directly on top of each other. It's unstable and they should be using a straddle hanger instead. So these errors occur just when design and practical installation just aren't quite aligned. Site issues can differ from the design errors, but are equally critical. So we can see here, we've got damaged or bent metalwork. I talked about those top tabs being crucial. And we can see there that they're not properly installed. The top tabs, they've been used maybe incorrectly. It's a weak fixing, so we can see some there that they're not actually in the timber. So that will definitely impact the load. There's alternative fixings that have been used, so we can see there's some screws along with they've packed that detail out to match the width of the hanger. It's just an untested detail, and the proper fixings should be used as well. In that image on the bottom right, we can see there's a couple hangers where the truss, it's a truss that's in there, a truss hasn't been seated properly, and the hangers are tipped downward and the load is sort of shifting to that weaker point of the hanger away from the header connection and the nails. So that will weaken that connection. So correct seating and the full fixings are essential to maintain the performance of the hangers. And then just very quickly, we also do custom welded hangers. These are for projects beyond the standard range that we've sort of talked about, and they're different from our standard welded hangers as well. They're tailored for specific angles, skewed or sloped, and then also higher load capacities. They're made to order. We can adjust the steel thickness and the geometry of them, and then also various fixings can be used like PSTS screws or bolts to further increase the load. This all depends on the strength of the header as well. They're ideal for complex or high-spec projects. And then to wrap up our sort of campaign on hangers and all the work that we've been doing previously, some of the available resources that we have. So we have the Cullen Technical Guide, which is regularly updated. Our new hangers site guide, which is released today. And in the next slide, we'll have a QR code that you can scan to have a quick look at that. We have the installation videos like the one that we saw today, and then also QR code packs that we can put on drawings. And this will help the guys on site if they're not sure about the installation process. The technical portal, so we have knowledge articles and part drawings on there to help as well. And then we also have our brilliant technical support and the customer services team for just a bit more help if you're looking for it. So this is our new site guide that was released earlier today. You can scan the QR code now to have a look, or we'll also send it out after the webinar. You can share this with teams on site. The guide contains installation details and it also provides some useful advice like common issues to watch out for.